The warm-up's asking to solve for the value of x. Is 56 a central angle or an inscribed angle? Central. So if the central angle is 56, what angle do we know automatically? Z. Z should be 56. Then we have a rule that says if the chords are equal, what has to be true about their arcs?
Equal.
They're also equal. So this angle has to, or this arc has to equal 56. Good. So then we add the 4. We have 60 equals 10x. So x has the value of 6. Good. All right, continuing on then. All right, so let's look at today's notes. Today we're going to look at, yesterday we looked at a tangent, and that one we were looking at the length of the tangent. Today we're going to look at arcs and angles, and if you just kind of glance at the notes, you notice that we have degrees here, right? So if we look at our formula chart, are the degrees formulas on the top section or the bottom section? You may want to look at the formulas to see what section it is. The top section. So we're going to be looking at 1, 2, 3, all the formulas on top today. All the formulas will be on top today, okay? So the very first one is this circle. Kind of reminds me of a wheel on a boat, or for some reason it reminds me of the sea. I don't know why. Don't ask me why, but it does. Which one's that one? You have 5 circles here. You have 1, 2, 3, 4, 5. Which one does that one look like? The fourth one, right? That's the fourth one. All right, so looking at the fourth one, if you notice, the angle is not in the center, right? There's no dot there. No dot. No center. No center's located for you. So no, it's not the central angle. Is it an inscribed angle? No. So it's somewhere floating around in the circle, but not in the center, not on the circle. Anytime you're looking for an angle inside, but not central, not inscribed, what we do is we take the average of the opposite arcs. So if this is your angle, you're going to look at its intercepted arc, which is the arc that kind of blocks it in, and you look at its opposite arc. So on my screen, it's the 2 red ones. If you notice, the arc, the angle, and the opposite arc kind of line up together. All right, so the formula just says that we're going to add the x and the y, which happens to be the arcs, and we're just going to divide them by 2. You're just taking the average. So the top arc, the bottom arc, divided by 2 gives you your angle. All right, so the first one's straightforward. The first one is just straightforward, okay? You're looking for the angle inside. So you're going to look for the arc that intercepts it, which is which one? The 130. All right, and what arc is opposite on the side of 130? 84. Okay, so you're going to take the 2 arcs, the 130 plus the 84, and you're going to divide it by 2. That's going to give us angle x. Okay, so what's 130 plus 84? 214. Divided by 2, that gives us 107. That's going to be the measurement of angle x. Okay, the next one, we're again still using the same formula. What do you notice about the arcs, though, that are given? They're on the opposite side. They're not with the x. Do y'all think we can still figure out the x?
Yes.
Okay, there's 2 different ways to go about it. Is anyone thinking, does anyone have a strategy here? Anybody thinking what they can do here? Yes, Sloan. What else? What do y'all think? What do y'all think? If I was to add the 2 given, where would the angle be? If I was to add these 2 and divide it by 2, what angle would I find? Where would it be at? AEB. It would be here, or it would be where? CED, right? It would be vertically across from it. So it would either be this one or this one. Okay, let's just call it Y. Let's go that route. Let's call it Y. All right, let's find Y then. So I had to add the Y. So 143 plus 75 divided by 2 is going to give us angle Y, which we added to the photo. What's the measurement of angle Y? 109. All right, so if this is 109, or this side's 109, wherever it is you want to place it at, right? Because they're vertical, they have to be the same. How do I figure out angle x in? Subtract it from 180. So x has a value of 71 degrees, yeah. Can anyone think of a different way to approach this one? This is one way. This is a solid way. Y'all saw this one? Good. Can anyone think of a different way? What was the first step? We had to add the what?
Y.
We didn't add the y. That was the second part. What was the first part? We added the arcs. You added this arc. And you added this arc. So if I'm adding those two arcs to figure out y, which we had to make up, right? We had to add. How do you think we can figure out the x's? If those two add up to one number, what has to be true about the other number? You're right, it equals the other number that would then add up to 360. So do y'all agree that the remaining piece, whatever this is, should add up to 360 because altogether they should all equal 360. Okay, so if I was to add instead, if I was to add 143 and 75 instead, what was the sum of that? Do you said 218? So if that's 218, I can get the sum of my red arcs by doing 360 minus 218. What's 360 minus 218? 114? 42? Okay, so if this one plus this one is 142, how do I figure out angle x? Just divide that by 2, and we still get 71 degrees. So option 2, if it's something you want to write down. This one is this is the one that most kids go with because they remember the 180 at least, and then just go with that given formula. But, you know, you can always go about it the other way. Whichever one you want to do. It's about the same amount of work. All right, last one. So if I have the angle or arc x, what's opposite of arc x? 97. Do I have the angle, the vertical angles, either one, that's in line with those two? You have 110, right? So this time they gave you the angle. So if they're giving you the angle, what are they wanting you to do? It's just working backward is all it is. So you'll still take the same arcs. You'll take the arcs given. So x happens to be 1. So x plus 97 divided by 2 gives me the angle. And what is the angle? 110. The opposite of dividing by 2 is 2. Multiply by 2. So x plus 97 equals 220. 97. And what's our difference of 220 and 97? 123. All right. Okay, go ahead and try 3. Try 3 without me. And then we'll go back to that question up on top. All right, anybody want to share their process on A? Tang wants to share. Thanks, Tang. All right, what'd you do? Good, equals. What was that number? 81.5? Okay. 81.5, everyone? Yeah, good job. All right. Thank you, sir. All right, next one. Who'd like to do the next one? You want to do it, Noah? Noah said yes. Oh, it's okay. We're going to do it together. All right, ready? All right, Noah, I gave you this one, and I gave you this one. What should we do with them? Good, just add them. All right, so add them together for me. Let me know what you get.
130.
He says this is 130. Good, divided by 2 for me now.
65.
Good, you got 65, but 65, is that going to be x? No, it's going to be one of these other two angles that align with it. And it doesn't matter which one you pick. So let's just say this one's 65. There you go. See, you can do it. 180 minus 65, what's our difference? 115. Good job. All right. Anybody want to do the last one for us so we can go on to the next one? Thanks, Eli. All right. What'd you do, Eli?
I multiplied 128 by 2.
Okay, so 2 times 128 equals 20, what is it? 256. And then?
Subtract 154 from 256.
154? So this is 154 plus x. So you said subtract 154. Okay, so what's our difference of 154 and x? 102? All right, thank you, sir. All right, any questions on these? That's the first one, which was picture 4. Okay, now to go to the next one. Next formula. On the last test we took, or on the test we took, we ended with this type of angle. Do you remember what this angle is called? Inscribed, correct. This next rule, all they did was they took the inscribed. Sorry, I'm trying to grab only the yellow part. Not inviting me. Let's try this again. What I was trying to do is move down the inscribed angle. So all they did is they took this inscribed angle and they just slid it down so it was at the bottom. So they took the same inscribed angle. All they did was bring it down. They moved it down so that it looks like this. Do y'all see where that slide would happen there? From the green one just to the yellow one, okay? So it's the same rule. It's doubling or halving because it's that inscribed angle being pulled down to the bottom. So just think of the inscribed angle when you get to that part. So let me just erase this real quick so we can go on to that one. Sorry, I was trying to slide it for y'all, but it wouldn't work. Okay, so halving or doubling. So if you're looking for angle 1, you're gonna half the arc. So looking for angle 1, you're gonna half whatever the intercepted arc is. If you're looking for 2, you'd half its intercepted arc. Before I continue, what do you think is true about angle 1 and angle 2? They're supplementary, which means they have to add up to 180. So just know that can be beneficial. Okay, so look at example 2. Angle QPR. Q, P to R is this angle here. So what would I do to the 148? Half it. 148 divided by 2 gives me 74 degrees. Then they're asking for arc, RSP. How could I figure out this angle or this arc?
180 minus 74.
We could do 180 minus 74. What's 180 minus 74? 106. That gives us this angle here. Double it. 2 times 106 is 212. Now, this is a tangent. And this one's your secant. Your secant line goes or touches your circle 2 times. Should have mentioned that from the first page. Just realized I didn't mention it. Any line that goes through your circle, for instance, on the last one we saw. Let me just draw the last roll here. The last roll right here. Right? It said this arc plus this arc divided by 2 gives us this arc. These are secant lines. Secant lines are pretty much chords extended. That's all it is. Because this is your chord. And all that's happening is that we're just extending it past the circle. So a secant line hits your circle 2 times. So this is not, it's not a secant line just because it's not going through this side. It's a ray. So we're looking at the ray and then we're looking at the tangent. So, but same thing though, you are going to still continue to half it or double it. The reason I pointed it out is because on the last rule that we look at today, we're going to look at tangents with secants, secants with tangents, and then tangents with tangents, okay? All right, so let's look at this last one. Sorry, I didn't mean to go off on a tangent there, but anyways. All right. D to F. How do I find arc D to F? What should I do? Double it. 64 times 2 is 128. Good. And how do I figure out DE to F? Subtract it from 360. We could do 360 minus 128 gives us what? 232. Because this is a tangent. It's just touching your circle at one point. Could we have done the second step on the first one? Could we have done 360 minus 148 instead? You could have. And again, either one's correct, whichever one you want to go with. Y'all can do that one. All right, just do one of each down here. So find me QPS first, and then find me BCD. All right, Michael, what did you do to find angle QPS?
QPS, I divided QP by 2.
Good, and what'd that get you?
125.
125, good. Everyone get 125? Yes, all right. What about the second one? Second one's looking for BC to D, and this one you could approach two different ways. How would I find arc BC to D? Anybody like to share what they did? Do what now? Double 108. Okay, so then 2 times 108 is 216. So if that's 216, how did we find the other arc? Subtract it from 360. So 360, take away 216, what would our difference be? 144? 144. Everyone get 144? Good, all right. So if you look at your formula chart, which equation was this one that we just finished doing? First, second, third, fourth, or fifth? The fifth one, it's the last one. Look at the last one, look at the formulas. We have angle X is the y degrees divided by 2. Or to get the y degrees, we have to double the X, okay? All right, the first 3 on that top section, are these 3. If you look at the formula though, what do you notice about the formula? They're all the same. They're all the same. So then the question is, how do I know I'm using this formula? Do y'all agree that the first 3 on the formula chart look like the middle 2 on the bottom part of our notes? Of our formula chart? Where it says, not the bottom part, but with the part that says segments created by tangents and secants. It kind of looks the same, okay? So then the question is, how do I know when we're using this? The way to determine it is by what it's going to give you. So here, this one, they're all on our notes, going to give you angle A. And angle A is this angle out here. Anytime that you're looking for that angle on the outside, that exterior point that they have in common, then this is where you're subtracting the bigger arc from the smaller arc. So whether it's a 2 secant, a secant tangent, or 2 tangents, it's going to always be the big arc in between the 2 lines. So the big arc minus the small arc. Again, the big arc minus the small arc. And if you notice, my arrow is staying in between the lines. The big arc minus the small arc. It's always the big one first, okay? I'm not looking at the arcs on the outside. So this one looks similar to yesterday's. The difference, again, this is looking for degrees. The one yesterday was not. So if you look at your formula chart, I made sure that the ones on the formula chart had the degrees on it so that you knew that's when you use a degree, okay? All right, so you're going to look here and you're going to say, oh, they're looking for, bless you, they're looking for the angle on the outside. So you're going to go to your 2 lines and you're going to go in between the 2 lines. You're going to say this is the big arc and this is the small arc. So again, it's the big arc minus the small one divided by 2. This is going to get us angle R. Okay, so then what's 140 minus 50? 90. Good. What's 90 divided by 2? That's 45 degrees. And that's one that's just straightforward. That means I gave you the two numbers. It's just a matter of subtracting and dividing by 2. The next one, though, what type of lines are they if they're touching it just one time? Tangents. That's yesterday, right? So because they're two tangents, there's one starting and one starting. Sorry, one starting, one starting. One starting and one's ending. That's what I meant to say. At the same point. So together, these two arcs have to equal how much? 360. So to find the major arc or the big arc, the major arc, we're going to take 360 and subtract 102. So what is 360 and the difference of 102? 258. So this is 258, and now we can continue on with the equation that we're using. So again, it's going to be the major arc minus the small one, or you can even say the big arc minus the small one. So 258 minus 102, or take away 102, divided by 2 gives us angle L. So what's 258? Y'all can just give me the final answer. What's 258, take away 102, divided by 2?
78 degrees.
What was that?
78.
78? Okay. All right, and the last one, because you always have to be able to work backward, is just the one working backward. Okay, so this one's looking, if you look at the question, is looking for the arc, but I gave you this angle. All right, so this is a good picture where someone might say, well, I thought the 56 was the arc. It's a good question to ask on the test. So if you're unsure what goes where, you can just say, Ms. Kranza, what number, where does that go? And I'll tell you. Okay, so this is the 56. They're looking for this arc. So it's the same steps. You take the major arc minus the minor arc, divided by 2, gives us 56. All right, just working backwards. So what's our first step? Multiply by 2. So we get x minus 95 is equal to 112. Good. And then what do we want to do with that 95? Just add it. And what's our difference here? Or what's our sum here? 207? Okay. And if you want to check your answer, you know that this is the formula. So you can plug in your answer here and say 207 minus 95 divided by 2, do I get 56? All right, we're almost done, guys. All right, go ahead and just try these two. One is straightforward. The other one's working backward. The 68 on the second one is angle Y. You're looking for X to Z. You're looking for the arc. All right, Jeremiah, do you want to do that first one for us to find angle S?
179
Mm-hmm.
minus 71
Mm-hmm.
divided by 2.
Mm-hmm.
54.
Your final answer?
Yeah.
Okay, 54 class? Yeah, okay, so that's going to be angle S. Thank you, sir. All right, let's do the last one. Who wants to try the last one for us? Tang said I can call on you, Nicholas. Okay, so what's the next one?
That's 80 degrees for the final answer. So 224
Mm-hmm.
minus x equals, or divided by 2
Mhm.
equals 68.
Good.
And multiply by 2.
Mm-hmm.
So then it's 136, or 224 minus x equals 136.
Mm-hmm.
Subtract 136 plus x, and equals 80.
Subtract 136, you said. Sorry, I was trying to follow that one last part. Subtract 136,
Add the x.
and then you said add the x, right? So he added the x on the other side. What did you get there?
88.
88. Some of us might have gone the other way. We might have done minus 224, which would have given us a negative 88. And then we would have had to divide by negative 1. Still getting the 88, though. So both ways are correct. Okay, last one. Or not last one. We're almost done. So the difference between this one and the last ones is just the expressions. So they're not, it's not just a number. It's not just x. We have equations there. Okay, but set them up the same way. The only thing I'm going to stress is that if there's expressions, leave them in parentheses for the first few steps. Okay, and I'm going to show you why. So what is our major arc here? Thank you, 13x minus 6. So we're going to have 13x minus 6. And then minus, what's the minor arc inside? Plus 14. All of it divided by 2 should give me 54. Okay, so same thing we did. Here's the major arc or the big arc minus the small one divided by 2 should give me the outside angle. Okay, so we get rid of the 2 the same way. So multiply both sides by 2. That part's not going to change. So this is 108. Good. On the left side, we're going to keep it in parentheses. And then who can tell me what the next step should be here? Distribute the negative. Correct. We got to distribute the negative. Okay, so we're going to distribute the negative to the second set of parentheses. So it's negative 1 times 5. It's negative 5. Negative times a positive is a negative. And then everything in the front just gets brought down. So nothing is changing in that first equation or the first set of parentheses. So we're just going to drop them at this point. And then it's equal to 108. Now we want to combine like terms. So what are my like terms here? 13 minus 5 is 8x. Good. What about a negative 6 and a negative 14? Negative 20. And then what do I want to do with the 20? Add it. Good. So 8x equals 128. So dividing by 8, we get 16. So it wasn't a horrible question. We just have to, the important thing with this one is the parentheses, because that negative distribution has to happen. You'll get an answer, just not the right one. Okay, last one. Do you remember yesterday the earth problem? Right, it wasn't bad once we got the numbers on there. They were like, oh, okay, I know exactly what we're doing. Okay, same thing with this one. This reminds me of an eyeball. I don't know why, but it does. All right, the diagram shows the path of a light ray as it hits a drop of water. The ray is bent or refracted at points A, B, and C. If A to C is 128 and if arc ABC is 128 and arc XBY is 84, what's angle B and then what's angle ABC? All right, A to C is 128. So let's go ahead and put 128 on A to C. And then I gave you that XBY, this arc here, is 84. Their question is, what's angle B? What should we do? Anybody want to share what they're doing? Good. And then divide it by 2. Good. That's going to give us angle D. Good. Thank you for sharing. All right. What's 128? Take away 84. 45? Was it 45? 44 divided by 2 gives us the measurement of D is 22. All right, you got D. All right, who can tell us what A, B to C is? It's 64. Good. Who remembers what type of angle that's called? Inscribed. 128 divided by 2 is going to give us angle ABC. And 64 would be our inscribed angle. So if you looked at it without reading the problem, it kind of looks like it's going to be a lot of work, but it was not bad.